we have here an electric meter. Hopefully you can see the scales on this meter. You can look along with the meter that you have, but notice that the meter's in the off position. Okay, it says off right here, and that's how we want to keep the meter off when it's not in use. Now we have different scales on the meter. The red scales over here are for measuring AC voltage, alternating current voltage, and we don't want to do that. We're not going to measure any alternating current voltage. This is for measuring direct current voltage over here. We have 15, 150, and 1000 volt scales. Anytime we measure current in these experiments, we're going to stay at a safe 15 volts. And let me stress in our directions here that in no way are you supposed to use these meters or do any of these experiments with anything but the equipment that we're talking about, because for example, if you plug the aluminum strips and the loop into your wall outlet, not only will the experiment not work very well, it'll probably melt the aluminum, electrocute you, and burn your house down. So don't step outside the instructions that we're giving you in these experiments under any circumstances. Okay, so we have a 15 volt scale here, and the voltages that we get from these generators are in the range from 0 to about 15 volts. We don't have any use for the 150 or the 1000 volt scale, and you don't have any business measuring 1000 volt currents unless you're well trained anyhow, not even 150 volt DC currents. Very dangerous. We also have a resistance measuring scale. It says R times 1 kilo ohm here. We have the off position, which is where we turn it every time when we're done with it. And we have a 150 milliamp DC scale here. Okay, that's the only current measuring scale that we have. Now you measure, when you read a scale, if you're on the 15 volt scale, you read this bottom scale that goes from 0 to 15. If you're on the 150 milliamp DC, again, you read on the 0 to 15 scale. I'm sorry, you probably can't see that, but you read on the 0 to 15 scale down here at the bottom. Even if it says 150 milliamps, you just move the decimal in your head. You think 15 means 150, and you respond to the readings on the meter appropriately. When you're on the 15 scale, of course, you're just going to read directly 0 to 15. When you're reading the ohms, the resistance times 1 kilo ohm, you're going to read on the ohm scale up here. And the ohm scale goes backwards, and we'll see why that works perhaps later on. But it measures in kilo ohms, thousands of ohms of resistance. To use the meter, we plug the black clip into the negative over here. This says negative, this says positive. Black goes negative, red is positive, and we see how this side is marked in red to indicate that the red clip goes in here. Now that's very important for some applications. For the applications we have here, it's not all that important because you don't always even know which side of this thing is positive and which is negative. Now I'm going to put this on 15 ohms, and I'm just going to crank directly through the meter. Now usually when you measure, I said 15 ohms, 15 volts. Usually when we measure volts, we're going to want to know which is positive and which is negative. But right now we're just going to use an experimental approach. I'm going to crank the generator here, and nothing's happening. Either because we have bad contact here, that's it. Now these things don't fit in there very tight, and they just weren't in real tight. I'm hoping I can get this thing to work in the upright position, but it doesn't look like it. So I'm going to have to move it into this position, which is going to make it pretty hard for you to see. So you're probably not going to get to see this until you do it yourself. But when I crank the generator, what happens is the dial moves to the right. If I had an extra hand, let's try again. Let's see if we can get those jammed in there. I just don't want to do it. I don't have an extra hand here, so I can't crank and hold these in there. There we go. Okay. Now if I crank the wrong direction, if I crank this thing backwards, the meter is going to go the wrong way, and we don't want that to happen. That can damage the meter. We also don't want to crank so fast that the meter goes over here and pegs. That is, gets to the end there and just gets stopped by the fact that it can't go any further. That's not good. Of course, it's very difficult to crank this thing fast enough to peg this meter, but on some meters it would be very easy, and that's just a principle in meters. We never want to peg the meter. Notice that this is a series connection, okay? I've just connected one generator lead to the red, one generator lead to the black, so that the current goes in one side and out the other. That's not usually the way we measure volts. We usually measure volts with a parallel connection. We measure amps with a series connection like this. Now let me switch the meter over to measure the milliamps. Now one thing we've got to be very careful of when we're measuring amps is to crank very, very slowly at first. And I guess we don't have contact again. No, this meter just doesn't want to behave. It works fine if I lay it down. The idea, this is really a cheap meter. It's really an inexpensive meter. And why the thing is designed so that these leads don't really fit in here very well, I just don't have a clue. I don't know why anybody would design a meter with that characteristic, but they do tell you in the directions to their credit that the meter should be lying flat, and you should lay the meter flat. Now again, I think I might have been out of the picture in that, but I was trying to make the ammeter work, and it's just not going to happen unless the meter's in the flat position. We start cranking very slowly, and with an ammeter we have to be in series. We never want a parallel connection with an ammeter, and I'll explain a little bit more about that in a minute. Okay? Now we'll look at how to connect the meter into a couple of circuits that we're going to use in the experiment, but we'll do that on the next part of this clip.